Welcome to This Explainer. Today, we're decoding the mechanics of that invisible blanket surrounding our planet. We'll be breaking down how it dictates our daily weather, shapes global climates, and literally creates the lived experience of our seasons. If you've ever looked up and wondered what's really going on up there, well, let's get right into it.
So let's kick things off with a pretty wild thought experiment. What if this complex mixture of gases pulled down by Earth's gravity just wasn't there? The planet would be completely unrecognizable. I mean, we wouldn't just be gasping for air, we'd have absolutely zero shield against harmful solar radiation. And worse, without a way to trap the sun's heat, all that life-giving energy would just bounce right back into the freezing void of space.
To demystify the sky above us, here's our roadmap for today. 1. Our invisible planetary blanket. 2. Slicing the atmosphere. 3. Weather versus climate. 4. The mechanics of wind. And finally, 5. India's rhythms and seasons.
All right, Section 1. Our invisible planetary blanket, the composition of the air we breathe. Let's start with the very air we move through every single day. When you look at this breathtaking view, it really hits you that the atmosphere is essentially just a massive blanket held in place by gravity. It's this gravitational pull that locks this vital mixture of gases around our planet, acting as a literal shield from the extremes of space while trapping the exact amount of solar energy we need to survive. Now, when we think about the air, we naturally obsess over oxygen, since we breathe it, or carbon dioxide, which obviously dominates climate discussions. But take a look at this breakdown. The overwhelming majority of the air we interact with, a massive 78%, is actually nitrogen. Oxygen makes up 21%, leaving everything else as a tiny yet incredibly significant fraction of the whole shebang. Moving right along to Section 2, slicing the atmosphere, traveling from the ground to outer space. We know what it's made of, so let's travel upwards and slice it into its distinct layers. The key thing to grasp here is altitude, because as we move higher, the density of our air drastically decreases. But here's a crazy fact. Right down here at the surface, the air above us is exerting a massive amount of physical weight and pressure on our bodies. We don't feel crushed simply because the pressure inside our bodies exerts a counterpressure to perfectly balance it out. Let's ride the elevator up. First, we've got the troposphere, our home up to 12 kilometers, where nearly all weather happens. Above that is the stratosphere, reaching up to 50 kilometers. It houses the crucial ozone layer, and since it's practically cloud-free, it's the smooth highway for commercial planes. Next up is the freezing mesosphere, up to 80 kilometers, where space debris and meteorites burn up. Then the thermosphere stretches way up to 700 kilometers. Temperatures skyrocket here, and it bounces radio waves back to Earth. And finally, the exosphere, the uppermost layer where the air is so thin that light gases just kind of float off into the void. You know what's really fascinating? There's a stunning phenomenon happening right in that fourth layer, the thermosphere. This is where solar wind, basically charged particles emitted by the sun, slams into our atmospheric gases. When these particles get funneled toward our magnetic poles, they cause the gases to glow, creating the incredibly beautiful visual displays we call the auroras. Okay, Section 3. Weather versus climate, unpacking the differences. Having seen the massive scale of the atmosphere, let's zoom back in on how it actually affects our day-to-day lives. This is a super common point of confusion. People constantly use weather and climate interchangeably, but they operate on totally different timelines. The easiest way to think about it, weather is like your mood today. It dictates if you need to grab an umbrella or sunglasses. Climate, on the other hand, is your overall personality. It's a sum total of those weather conditions measured over an extended period, usually 30 years or more. The foundational driver for both of these is insolation. That's the incoming solar energy intercepted by Earth. Because we live on a sphere, sunlight strikes the equator dead on, making it incredibly hot. But as you move toward the poles, that exact same amount of energy gets spread out over a much larger area at a lower angle. That drop in concentrated energy is exactly what creates these distinct temperature zones across the globe.
Alongside temperature, we have to talk about water. A crucial rule of thumb here is that warmer air can hold a lot more moisture. When humidity is high, we feel sticky and miserable, not just because the air is wet, but because our sweat evaporates way slower into air that's already saturated. Once the atmosphere hits maximum capacity, that vapor condenses, gravity takes over, and boom, we get precipitation, whether that's rain, snow, or hail. Next up, Section 4. The mechanics of wind, how air pressure moves our world. We know why it gets hot and why it rains, but what causes the wind to blow? It absolutely all comes down to pressure. Atmospheric pressure is literally the weight of the air pressing down on the Earth's surface. And here's where it gets really dynamic. Air pressure changes based on temperature. In hot areas, the air heats up, expands, and rises. This creates a low-pressure zone, which is typically your cloudy, wet weather. Conversely, in cold areas, the air is heavy and sinks, creating a high-pressure zone, bringing clear, sunny skies.
So, what is wind? Wind is simply nature's way of balancing the scales, air moving from those heavy, high-pressure areas into the lighter, low-pressure zones. And this invisible movement scales up dramatically. A tiny pressure difference gives us a calm breeze where smoke just rises vertically. A bigger difference rustles the leaves. But when the pressure drops massively and suddenly, we go from strong breezes that wreck your umbrella all the way up to devastating storms topping 100 kilometers an hour.
Let's apply this to a regular day at the beach. During the day, the land heats up way faster than the ocean. That hot air over the sand rises, creating low pressure, so the cooler, heavier air from the sea rushes in, giving us a refreshing sea breeze. But at night, the whole process perfectly flips. The land cools down faster than the water, creating high pressure over the land, so the wind blows out toward the warmer ocean. A land breeze. It's atmospheric pressure in daily action.
Finally, Section 5, India's Rhythms and Seasons, Bridging Ancient Wisdom and Modern Meteorology. Let's bring all these grand global mechanics down to a specific human experience.
The Indian Meteorological Department actually classifies the country's rhythm into 4 seasons, but the undisputed dominant force is the advancing monsoon from June to September. This happens when a massive low-pressure area forms over the intensely heated subcontinent. This acts like a giant vacuum, drawing in incredibly humid southwest winds straight from the Indian Ocean, dumping vital rains before retreating later in the year as temperatures finally cool.
But what is absolutely fascinating is that traditionally, India experiences a 6-season cycle known as ritus. The year is mathematically divided based on astronomical observations, giving us highly specific seasons, like Vasanta for spring, Grishma for summer, and Varsha for the monsoon. This deep, granular understanding of atmospheric rhythm is embedded right into the culture. There are even specific ragas in Hindustani classical music composed specifically to evoke the exact mood of these shifting winds.
And this historical connection goes far beyond music. Because agricultural survival absolutely depended on these shifting, pressure-driven winds, ancient Indian scholars were remarkably advanced meteorologists. Texts like the Krishi Parashara detailed complex methods to predict rainfall by meticulously tracking the sun, the moon, and the stars. And remarkably, many farming communities still reference these ancient astronomically driven methods to plan their harvests to this very day. Which brings us to a really powerful realization. From the nitrogen we breathe, to the pressure differentials that rustle our trees, to the seasonal monsoons that have shaped entire civilizations, we are forever connected to the invisible forces above us. As we wrap up this explainer, I want you to consider this. Whether we're tracking atmospheric layers with modern satellites today or predicting seasonal rains by looking up at the stars thousands of years ago, hasn't our very survival always depended on understanding this incredible invisible blanket? Thanks so much for joining me on this deep dive. See you next time.